Alright, here's the problem. The goal is to solve it using matrix row reduction instead of just, standard substitution. It'd be easy to do with substitution, but for our purposes, we want to do it with matrices. So I'm going to start now. So the first thing you would do if you want to solve a system of equations with matrices, you would take the coefficients of your variables that you're looking for and put them in a matrix of the correct dimensions. So for us, we want a 2 by 2 matrix with all of these coefficients here. So the first coefficient of x would be 1, second coefficient of x would be 5, and make sure your variables are in order. Like this will be the x row, this will be the y row. Okay? So the first coefficient of y is -7, and second coefficient is 2. And then you have a matrix of your variable, x, y. And then you would have the matrix of your solutions, which would be -11 and -18. And you can kind of notice, even right from here, that like if you were to multiply out this these two matrices, you would get the equations above, which is what you want, right? So like if you multiply 1 by x, -7 by y, you would still have this equation here, 5, 2, same thing. So now that we have this kind of system, what we can do is set up an augmented matrix, which would look like this. You're going to take these answers, you're going to write out your matrix, 5 and 2, and you're going to put a line, and this is like a line saying if it's equivalent. This is where you can start doing row reduction. And now that we have this, we want to start reducing this side of the matrix to an identity form. An identity matrix looks like this. Okay. Once we do that, we know that since we're still multiplying by this x and y, we just kind of left it out, that whatever value you have over here will be your answer. And I'm kind of jumping the gun, but you'll see in a second. So first off, we need to get this 5 to be a 0. Just like over here, we want a 0. So we're going to do -5 row 1 plus row 2. So 1, -5 times 1 plus 5 is going to be 0. 7, these will stay the same. These values of row 1 aren't changing. -7 times -5 is 35 plus 2, 37. -11 times -5 is 55. 55 minus 18. 55 minus 18, 37. Okay. The next thing we want to do is get this value to 1, so we'll divide row 2 by 37. So 37 divided by 1 is 1. 37 divided by 37 is 1. 37 divided by 37 here is 1. So now we want we want to multiply. We want to get this value to be 0, right? Just to get, remember, we're trying to get this identity up here. That's 0 there. So we're going to do -7 row 2 plus row 1. 1, 0. This row will stay the same. This will all stay the same. These two are going to change. The reason this value stays the same is because you're adding 0. You know, -7 times 0 plus 1 is still 1. So -7 times 1 is -7. Oh shit, this is supposed to be a +7. Good thing I caught that. So +7 times 1 minus 7 is 0. +7 times 1 plus a -11 would be the same thing as -11 plus 7. That's 4. -4. So that should be your answers. Let me check to make sure that's right. Yep. So now that you have this, you can put it back in the form that we had it originally, which is 1, 0, 0, x, y equals -4, 1. And like I was saying before, you can now multiply this out. You will have x plus 0y equals -4. And you will have 0x plus y equals, I'm just doing this row multiplied by that row equals this -4, and this row multiplied by that row equals 1. And then these would, not be relevant. X equals -4, y equals 1.